Ajay sir, are you there? Ajay sir, are you there? Ajay sir, are you listening my voice? Ajay sir, we can't hear you. Please unmute yourself.
Hello, am I audible?
Yeah, you are audible, sir.
Okay.
So should I start, sir?
Yes, definitely you can start. So I will share my screen first.
Yeah. So we are thankful to Dr. Ajay sir that he accepted our proposal to accept as a resource person. He is Dr. Ajay Kumar. He did BTech from Government Engineering College. I am just studying 2, 3 lines or 4 lines about him because of time constraint. Otherwise, it will take more time. Like he did BTech from Government Engineering Colleges. He did his master degree MTech program from IIT Guwahati and PhD from IIT Roorkee in 2013. His teaching and research experience nearly of 17 years and specialization in structural engineering. His area of interest is concrete and advanced material, green buildings. These are his area of interest. He has completed many sponsored projects. I think 4 sponsored projects he has completed, and presently one of the sponsored project is going on. And for consultancy project, I think 1500 consultancy project is presently going on by sir. Sir, your research publication is nearly 105, which are very good journal paper, and your citation is more than 1000, sir. Your H index is 19 and cross reference journal is 140 citation, which is again a very prestigious moment for us to listen your voice. Your award and recognition, you received All India rank in GATE 2008 conducted by IASC Bangalore in 228. Your percentile is 97.31. You are the first rank in BTech Civil Engineering awarded Outstanding Reviewer Certificate from elsewhere. Your teaching highlight is awarded a very good teacher grade as per online feedback system given by students. You have guided 15 PhD scholar and you have guided as a sole supervisor more than 29. Sir has guided more than 29 MTech students as a sole guidance. And I think BTech students he has guided more, many more, which is I think more than 100, sir. He presently he is associate professor at NIT Delhi, and his research journal, once I'll go through each and every one, then I found that, sir, in your SCI impact journal, is highest impact journal is 5.616, which is in composite structure. So all of our participants is very much interested to hear few words from you. Sir, over to you. Please share your screen. and myself, Anjani Kumar Tiwari, as a coordinator, and Jitendra Pratap Singh as a co-coordinator of this FDP, welcome you in this FDP for the last session. Ajay sir.
My screen is visible.
Screen is visible, sir, and your sound is completely audible.
Very good evening to all the participants, and thank you very much for nice introduction. Thank you for the coordinators of FDP, Jitendra, who has coordinated for this nice lecture for the FDP series and for the ATAL FDP programs. This is my topic for this time. Because sustainable construction is nowadays main focus of our institute. Means all the things you can say sustainable construction using geopolymer concrete is the main area which has been in very much highlight nowadays because sustainable construction is the requirement of the day. I think everyone is knowing because of the topic is limited to that. Sustainable construction, what it means, because we are depleting sources day by day. That is why some sustainable things are required. Sustainable construction things means that are not means that are not depleted very fast. Things of the environment are depleting fast. To maintain the quality and other things of the structure, we have to make it as a sustainable construction. That is the reason this is program is very important so that people understand what is sustainable construction. So geopolymer concrete is the area currently which I am working, as this has told that the this current project is going on. So this is the area in which my current project is going on. So that is why I am delivering topic on this so that geopolymer concrete and what is the benefits and why. That is one of the reasons. Let us see is cement concrete, because we know what is cement concrete. Everyone is knowing that because it's a very popular material, so that it is very good in compression and it has more advantage per capita usage next only to the each ton releases equal amount of CO2 need of alternative materials, because cement concrete is the very much popular in construction industry, so that we know that it is good in compression and there are many advantages due to which it is now still now in use. But we know these days you can see that it is just next quarter as per capita usage. But usage you can see that it is CO2 amount what it is releasing, it is very much high in this. After China, India is the second largest CO2 emission during this same cement concrete production. So that is the reason need of alternative material is there, because CO2 is not good for our environment part. That is why need of alternative material is required. That is why this material, this research is going on to compensate for this means less use of the environmental sources so that we make less emission of CO2. That is the purpose of this research. Portland cements, we know that is commonly used in this. So it is most energy intensive and consumes 4 gigajoule per ton of energy, and major ingredients of it is concrete and it has less shell life. Shell life. This is the cement and one. So that is why we are going to cementitious materials, because cement is producing a lot of CO2. That is why we are going for the cementitious materials. So some materials that we already know that are having cementitious properties, like industrial waste and marginal. So we have to, because disposing waste is also an issue nowadays, because waste is not easily disposable. So its disposal is also a challenge nowadays. That is why it is also important we have to see waste also as during the construction process, so that disposal issue is solved and our things are at the better place, and we can use the industrial waste. We can use the industrial waste, and that is why it is important. We should focus how we can use the industrial waste and how we can combat the challenge of emitting large CO2. These are the important things. We can see that that is the reason why we are going for this research work, and this is the requirement of the time that industrial waste should be properly disposed of, and their disposal problem is also solved, and their use is also there. So cementitious materials which are having properties similar to cement, that are now more focused by the researchers. So that fly ash we know that is also having cementitious properties. That is the reason GGBS also we know that is having cementitious properties, lime, gypsum. That is why we are going for these products which are having cementitious type properties, so that they can be replaced by the cement. And as you know, 30% of fly ash is allowed in our IS code also, that can be replaced by the cement part, so that we can have the some less amount of cement. That less amount of cement means it is less CO2 production. That is why we are now moving to some alternatives to OPC. OPC is the still widely used, but we are now coming to alternatives to OPC so that our CO2 amount release is less. And there is also one thing that we have to move for. That is the reason we are going for the potential use to this alternative to OPC. We are using that, and, and this is the construction. The best way to dispose of that, we should use this also cement OPC one part, but other cementous part also. So that disposal problem is also solved and CO2 emission problem is also solved. That is the reason CO2 footprints, carbon footprints, we have to reduce as per the our agenda of our government also, and as per the agenda of our environment also. That is the reason this topic is more applicable nowadays because it is more of the concern of the not only for the nature but also for our disposal of the waste problem also. You can see that there is a worldwide carbon emissions. You can see that carbon 10 to power 9 metric tons is there. The total is this by this graph total is shown. And liquid fuel also you can see and solid fuel, gas fuel. So different are the sources from this carbon emission in metric tons is shown in this 10 to power 9. And this is the year wise it is showing. So that is why we can see the carbon emission is very much high due to this emissions. So this is the mitigation of global warming is required because we know environmental part is depleting day by day. So that is why mitigation of global warming is required. So that conservation is required, and the energy needs also we have to reduce and recycling. Earlier we were just going for one-way cycle. Nowadays it is recycling. Means whatever we use, it should be recycled. It should not be disposed of by something like that. We can say that is also one main concern. So conservation is one part why we are focusing on it. So that energy power is reduced and recycling is there. Earlier, recycling was not there because we were using it and just wasting it and disposing it in waste. Nowadays, its recycling part is also important. That is why conservation is one thing, and alternative energy sources from which we can produce this nuclear also, wind also, geothermal also, hydroelectric also, solar also, fusion also. These are the alternatives energy sources by which we can make the our we can make the use of that so that our use of the CO2 emission part is less and we can use this also as a part of this our construction work. So how is it possible in construction industry? So because construction industry is very big industry and nowadays you can see that government is highly focused on the construction industry part. That things are become more challenging nowadays because CO2. Because if you go for the construction, then cement is very essential part, and we have to produce more to meet the requirements of the construction industry. That is why we have to focus on this. So that is the reason we are here to how these things can be just by geopolymer concrete. So replacement OPC by fly ash, already we have seen that these are the things by different cementitious bandits are there. And this is a normal percent level of the fly ash. If we use this fly ash percentage OPC, it is 0. So then it is required. So this means we can say that by this percentage, we can see that geopolymer, you can see that it is 100%. 100% replacement is there by geopolymer. So with geopolymer, we can use 100% replacement can be done. And you can see the OPC, there is normal, not use blended cement. We are replacing by 30%, high volume fly ash concrete 55%, and FPLG by 100%, geopolymer also 100%. So 100% we want to replace it this CO2 emission part by replacing this by using geopolymer concrete. So we can see that what is geopolymer, then we should know what is geopolymer. So so what is geopolymer? It is activation of natural materials like clay, etc. And geo means it is available in Earth's crust, and polymerization means cementing materials. So you can see that cement is replaced. Now cement is OPC is not there, and we are using polymerization by using the cementing materials. So this is the thing why we are going for the geopolymer because we are activation of the natural materials like clay, etc. And it is available in the Earth's crust. That is why it is called geo. And polarization means cementing materials and low carbon footprint with there. As we are replacing it, these OPC part, then it's why its carbon footprints are less. So you can see that this is the use of this and this is the essence and importance of this. The geopolymer concrete is replacing the OPC part. That is why it is also causing our pollination part also by cementing materials. So that is why our cement requirement is less. In the by Professor Joseph Davidos in French scientist was there in pyramids in Egypt. She gave this some idea and posted a theory 4,500 years ago, which was not very much clear at that time. So coal ash, we can see that coal ash is in India, electricity at 65% coal burning, coal ash is there, and coal reserves expected to last greater than 100 years, and fly ash is there. These are the parts like cement and fly ash, which are nowadays also used in this part. Fly ash, already we know that from different part by product of TPS rich in silica and aluminum, finer than it is cement, spherical in shape. So this is also one part of this cement. So, and then ASTM classification of fly ash is there that class F is calcium is less than 5%. It is anthracite coal and not self-cementitious, very common across the world. And class C is calcium is greater than 15% lignite coal and self-cementitious is there, and lot of commercial values there in this C part. So fly ash, some idea we will have. So before going in geopolymer concrete, we should see that some guidance documents are also there. Fly ash quality assurance by ACI 229R control low strength material. It is there. And ASTM C311 sampling and testing fly ash or natural polymers for use of Miller emission Portland cement concrete is given by ACTM. And ASTM C593 is for a fly ash and other polymer for use with lime. Which this I am showing that these are the current practice. After that, we'll see what changes will be there after the geopolymer complete industrial cycle. So there are guidelines for use of coal combustion by products in structural fields. And this is the slag. This is also one alternative synthetic material which we go for. And this is the GGBS. And this is the waste from the ferrous industry in which is quenched ground granulate GGBS rich in silica, aluminum, and calcium is there. So this also one part of the things which are going on nowadays. And metacolin is also one part we are using, which is burnt at high clay and high temperatures, highly reactive. It is there and it is contains silica and it can replace cement, but not economical. So we are showing that currently what are cemented things we are using it, but they are not. You can say that after that geopolymer, you will see that it is also not very much costly and it is also replacing in a more effective way. These are the current practices which are going on nowadays. Silica fume also we use in a construction percentage. It is having greater than 90% silica and it is finer than fly ash and 1 micron is the size. Condensed form can replace cement also. So these are the properties of the binders. Finally, because we are making, we have to bind the things. So that is the reason whatever metal we use, it should able to bind the things. So this is one chemical, this is one table which is showing different binders and which we are using that and how much percentage composition percentage there of different parts of the oxides that are present in the cement part. So specific gravity of fly ash is 2.35 and Fe1, Fe2 and Fe3 and different specific gravity GGBS has specific gravity 2.5 and percentage of residue left on 45 micron is 128.8. So we can see that different fluids 0.06, what is the percentage CO, what is the percentage by this, because we know this percentage will decide how the property of the mix will behave. That is the part I am showing this chemical composition because different oxides react in different ways. So that this is the different type of fly ash percentage which we can use as per the requirement of our work. Because different type of cements are there, you also already know. Similarly, for the different requirement of the work, we can go for the different compositions by using the fly ash availability by different residues as available in the 45 micron C. So let us now, these are the all the things which we know already the similar use. Now let us go for what is ingredients of the geopolymer concrete. You can see here, geopolymer concretes is having sodium silicate, water, sodium hydroxide, sand, and fly ash. You can see there is no OPC in this. So cement is there. So that is the reason earlier researchers were doing that cement was already in use. So that is why CO2 we have to produce. But now you can see there is no cement. That is why CO2 footprints are reduced and we are more focused towards less production of CO2 by using this amount of sand, fly ash, sodium hydroxide, water, and sodium silicate. You can see there is means you can say no cement. You can say that is the reason we are going for this particular ingredients of geopolymer mortar. And how it is activated, you can see this by this formula we go aluminosilicate. You can see that in this sodium silicate is there, water is there, sodium hydroxide is there, and sand and fly. So we can see how this will be in picture. So reactions will be of this type. We do not have some reactions of different part like you can see sodium silicate will be there. That is why sodium silicate, aluminosilicate reaction is going on. When we use this, then in the OH minus plus M minus, so this reactions goes on in the medium and this dissolution part something like this and SiO4 is created and AlO4 is created. and crystalline structures opens, polymerization occurs, then it makes oligomers, then it's crystallized, then crystalline structure is formed. After that, polymerization is there, then amorphous molecules are formed. So this is the way how the different reactions are going on in case of the geopolymer concrete. Earlier, there was cement properties, but now it is some geopolymeric reactions, something like this. Polymerization occurs, and oligomers are made, and crystallization occurs, and crystalline structures are made, and polymerization is there, then amorphous polymers are made. So this is the way. So then why water is used here? Because in the you know that in OPC cement we use water and cement mixture is there. So exothermic reactions goes on. While then still water is used here. Now water here is used for, you can see that water is here used from alkaline solution. It is using for the making of alkaline solution, and it is released during geopolymerization. This is geopolymerization is going on. So it is released during geopolymerization, and it is not used for curing. You can see now geopolymer concrete is not only reducing the cement content, but it also reducing the use of water, because curing is very much important part, as we already know. But you can see that in this, water is not used for curing, but it is used just to make alkaline solution, and it is released during geopolymerization. So that thing, you can see that what is the need of the time. Water should be less, and curing we should do less, because water is very less, especially in Delhi it is very less. So that is why it is more of the less, you can say, important part in some regions where water is, all over India, water is very much going down and polluted. So that's why water requirement is also reduced, and cement requirement is also reduced. So you can see that that is the reason why this research of geopolymer concrete is taking some focus. And how this making of geopolymer is done. So you can say that its making is same as the cement composites, but the change in ingredients are there. And cement to aluminum silicates, it is there. Example of aluminum silicates will be fly ash, GGBS, silica fume, metacolin, ricer's gas, and red mud, etc., which are locally available material. And making of geopolymer, we use same aggregate, and water we are using for alkali solution for 8 to 14 molarity. It's the molar solution we make. So that is important. Water is used to make alkaline solution of 8 to 14 molarity solution we make. And sodium hydroxide and sodium silicate is there. Potassium hydroxide and potassium silicates is there. Then what reaction goes on? Then sodium salts plus water, they mix it, and they make the alkaline solution. This is the part how the this this reactions goes on in this case of the making of the geopolymer. That is the thing. Aggregates is same, but water is here not used for a curing purpose. It is used for the alkaline solution, in which 8 to 14 molarity we make of the solution. And sodium. That is why geopolymer is not related to only civil engineers. It is also related to chemistry people also, because it involves the reactions. So involving the reactions means we have to do some chemistry part also. That is why you will see that geopolymer part is also done by the chemistry people. So many chemistry people are also working in this, so that its availability is more, and its understanding is more, because making the molar solutions and other things, it should be made as per the requirement. So that is the part we are going. Is you can see that many chemistry people are also working in this geopolymer concrete, not only civil people, because of these reactions. After this reaction is done, then process of making is that sodium hydroxide is there, sodium silicate is there, and coal-fired power plant, that we mix this sodium oxide and sodium silicate solution. Then we make highly alkaline solution. From the coal-fired power plant, we get the source material and the aggregates we will use. Then curing is oven or means ambient temperature curing is there. It's not water curing, it is oven or ambient temperature curing is there. Then geopolymer is made, and it is then used for the making of the cubes and other parts, similarly as we do in other parts of the mix. This is the way how its production is done. So you can see process of making is some sodium oxide solution is there, sodium silicate. Then we make highly alkaline solution, and this is coal-fired power plant. We use this waste. This waste is used here, and after that we use these aggregates as usual aggregates we have. Then curing in oven or ambient temperature curing is there. Then geopolymer is made, and then we use it in making of the tubes, etc. Whatever site work we have. You can see that reduction, we are not using here, not producing here CO2, because cement is not there. You can see, and water is also not there. That means our cement and water problems are, the cement CO2 production is reduced, and water is use is also less in this case. That is why our requirement of the time is met using this. You can see that alkali solution is made, the ash we will use, then this geopolymerization occurs, and slags we will use also. red mud and fiber we will use, and then fly ash based geopolymer cement concrete is made, and fly ash based geopolymer adsorption and emulsion of material can be done. After making this, we can use it for different use of our building making and other parts. Whatever RCC was used in previous case, we can samely we can use geopolymer concrete. So how this tank is there, as we know, different fly ash is there. When fly ash class F is there, then geopolymerization it occurs at elevated temperature of 60 degrees Celsius. And GGBS when used, hydration occurs and thermal energy is not required in this case. And if we use fly ash plus GGBS, then geopolymerization plus hydration is there, and thermal energy also not required. As per this, whatever we are using this product and this extra product we are using, the coal fired power plant, this source material, but its source material is changing by fly ash class F. If the source material is GGBS, then thermal energy is not required. And if we are using source material fly ash class F, then at elevated temperature, such a geopolymerization is occurs. And we are when we are using source materials fly ash plus GGBS, then in that case geopolymerization per hydration is there and thermal energy is not required in that case. So as I told you, then these are the parts of the this geopolymer concrete we have to use make some solutions on. So and these what molarity we are making of the solution that we know molar solutions are there. That's very important. So molarity in this case the concentration of alkaline solution we have to see, and for the NaOH will be 40 gram per molar, and 1 liter of water plus 40 gram of NaOH is one molarity. This is the definitions which we know what is the definition of one molarity. So that is why chemistry in which we have read all the what is molar solution, what is molarity, that also comes into picture. Those definitions also comes into picture. That is why some chemistry people are also working on this also because these are reactions which they can do in their lab to make the molar solutions. For 20 molarity solutions, we have to multiply by 40 into 12. Then for 80 gram of NaOH in 1 liter of water we will make. Then ratio of NaOH and NO2 SiO2 is there. This is the way how the mixture in the lab we can make of this molarity solution. This molar solutions we have to make. You can see this Na sodium and HNO, and this is the reaction that makes this Na2 SiO2. You can see this ratio of NaOH by NO2 SiO2 will be something like this. Bond will be something like this. This will be the picture that will be made in the lab. So these are the things in which chemistry lab we will make so that we can get the molar solution. To make this alkaline solution, you will use tap water plus sodium hydroxide, because you can see this alkaline solution we are using here. You can see this is the alkaline solution we are using here. This alkaline solution we are making in the lab. That is why I am showing you how this alkaline solution is made. That is the reason I am showing you the molar reactions and other parts so that alkaline solutions making is seen in the lab. So you can see this alkaline solution. So that's why alkaline solutions we are making in the lab. Tap water will use the sodium hydroxide plus sodium silicate that has been formed here. Sodium silicate has been formed here. And then we will make this alkaline solution, and then we will heat up to 80 degrees Celsius. Then we will stir it and cool it, and we will use it after 24 hours. This is the way how this alkaline solution is made by using tap water plus sodium hydroxide plus sodium silicate. The alkaline solution we make, then we heat up to 80 degrees Celsius, then we stir it by something this, and we will cool it and we'll use it after 24 hours. But as you know, these are the chemistry labs. I think everyone has worked in chemistry lab. There must be precautions because we are using with the chemicals. That is why we should have the precautions. So precautions are there that highly alkaline plus hot at early hours it is there, and not to touch with bare hands. That is why gloves should be used in this. So that is why this geopolymer concrete use some your expertise also. We means it's not every layman cannot do it. So that is why some background should be there that not to touch with the bare hand. Use protective measures. As we know in chemistry lab, some protective measures should be taken care of. Then if it falls on skin, then loss of skin is also there, and it takes long time for healing if something occurs. So that is why avoid falling of solution on skin, ear, and eye, etc. So that are these are the precautions when we are making this lab. So that is why I told you, because chemistry people already work there. So those safety precautions we take in chemistry lab. So same here also took in place. Highly alkaline plus hot at early hours it is there. So that is why not to touch with bare hands. Use protective measures. If it falls on skin, so loss of skin can also be there. Takes long time for healing, and avoid falling of solution, skin, ear, and eye, etc. So these precautions we have to make using this molar solution. And if it is there, then we have to immediately splash jet of water and affected air continuously. and irritation stops in minutes. If problem persists, then we have to consult doctor, and many researchers hide this information. Because geopolymer concrete we are working that, but we should know that these things also can be there if we are not taking precaution. That is why we have to be cautious by making this. So that is why if it is some ice problem is there, then we have to immediately wash the ice with clear water so that consult doctor and do not delay. It is these are the precautions because it is to our health. So this also we should know that geopolymer concrete these parts will also be there. We should be ready for this part, and whatever the things are required for the precaution that you have taken care of, we can use these glasses also. So and so there are some challenges also, as you know, the geopolymer concrete code is not there. Like IS 456 code is there, but it is not there. So maybe we are in process of making the draft of that code. So, but still it is not there. So there are some challenges also. What is the quality of fly ash where you are using that may not be informed, and GGBase also, and sodium hydroxide. Some it may be having some flakes, and sodium silicate solution that we have to make properly, and solidification also rock like it occurs, and trials are preferred. That is why these are the challenges by which we have to see those challenges. That quality of fly ash may not be uniform, and GGBS and sodium hydroxide flakes are there, and sodium silicate solution making also a challenge, and solidification rock like this is also there. And trials are preferred before finalizing the solution. And then geopolymers are something like this. When we make this, you can see this Na2SiO3 plus NH solution there. This will be used to make alkaline solution, and fly ash also we will take from here. Then alkaline solution plus fly ash we will mix. Then we will make get the mixed design, and then fresh GPC will be made. The geopolymer concrete fresh will be made, and this fresh geopolymer concrete will be used for making the cubes and reinforced GPS beams also. So these are the way by which we can produce geopolymer concrete, and we can use it in RCC beams also. It means these will be called reinforced GPC beams because we are using geopolymer concrete in this. Okay, and similarly geopolymer cubes are made here like this something. So these are the things by which we go for the geopolymer concrete. So what about the water cement ratio? Here water cement is not instead of water we are using here fluid. These are the changes what we get in the geopolymer concrete because water is not there. We are using replacing water by fluid because we are making solution, and cement we are replacing by binder. This is the change which we are doing this. So you know in this geopolymer cement is replaced by binder and water is replaced by fluid. So use of water is also less and cement is replacing by binder. Then cement is also not used here. So that is why that is requirement of the day that CO2 production is very less. Use of water is also very less during the curing. That is the reason it is becoming so water cement ratio will be replaced here by fluid to binder ratio. That is the important thing. Here water cement ratio will not be there because neither we are using here water as a pure and neither we are using here cement. So it will be not be water cement ratio, it will be fluid binder ratio in this case. And ratio by weight, you can see that ratio by weight will be mortar masonry 0.15 to 0.3, and plastic mortar will be 0.9 to 1.1, and concrete will be 0.3 to 0.6. So this is the change which we have done in the geothermal concrete. Water to cement ratio has been changed by the fluid to binder ratio. And these are the forms of the geopolymer. You can see this, and you can see that paste is there, then fine aggregates are there, then this is making mortar. You can see concrete is there, so machinery is there. That is the thing we are making using this forms of the geopolymer. So you can see it can be similarly, it can be made of any shape, as we know. So similarly, this like RCC, it can be molded to any shape like this. You can see cement paste of concrete is made, machinery is made, and mortar is made. So that is the thing. Forms of geopolymers you can see. And geopolymer paste, which is made by this fly ash plus GGBS per alkaline solution. We can see that in this we are using source material as GGBS, dominated granulated blast furnace slag, and this alkyl solution fly ash. So this makes the geopolymer paste now. You can see the cement is not there in this paste. That is missing here. That is the change in this geopolymer concrete we have done so that our requirement of CO2 is less and carbon footprints are less. That is there in this geopolymer concrete paste. So studies are going on. Alkaline fluid content, which is a constant function of respective normal consistency. So series designation, different trials we make. Geopolymer 1, geopolymer 2. This fly ash to GGBS ratios 100 to 1. And in this case, fly ash to GGBS will be 90 to 10. And this is different. This is GP1, GP2. These are different trials. by different using fly ash and GGBS base in percentage. You can see molarity of NaOH for geopolymer phase series is taken care of as per the molarity 12 for GP1 we have taken, and molarity means for this all the GP1 to TP12 it is molarity is 12, and molarity of NaOH is 6, 8, 10, 12 for the GP4. This is the thing. GP4 we are using molarity. So how to make this polymer miss solutions of the molarity, that is very important. That is the reason we have to take care of by different trials. So by making this as per the requirement, as we know, different requirements are there. Similarly, different cements were there, like sulfate resistant cement there, and low heat hydration cement are there. Same way, we can change the percentage of the uh, fly ash and GGBS and molarity also we can change to get the required content, the required effect of the this geopolymer concrete. That is why we see that GP1, G2 up to GP11 we have done, so that this ratio of fly ash GBS we have changed, so that as per the different ratio, we get the different property of the different required property of the geopolymer concrete. And the molarity also we can change. So you can see in this geopolymer concrete 4, in which fly ash to GBS ratio 70 to 30. In this molarity is 6, 8, 10, 12 is taken for that. And the molarity of M for NaOH is 12 for GP1 to G11 if you want to. These are the different ratios that will make the different type of requirements of the geopolymer concrete that will be used at the site. So studies on geopolymer concrete paste has been done. You can see this graphs has been plotted for this different geopolymer concrete GP1 to GP11. So you can see the compressive strength. This is for molarity 12, and this is M is for molarity 12, and this is for also molarity 12. You can see as per the age it is going, and these different colors are showing this, like GP1 to GP11. You can see blue is for GP11 and GP10 is for this. You can see that GP10 different age strength, the average complete strength is something like this. And for this GP10, we have used this 10 to 90 ratio. Fly ash is 10 and GGBS is 90%. So this GGBS waste is also used from those plants. That is also covered in this case. So you can see that how the strength is changing by different things, different molarity for different geopolymer concrete having different fine aggregate to GGBS ratio. You can see the strength. So as per the strength for different days, you can see that after 28 days strength, we can see that different for this fixed molarity of 12, the change of this graph has been put it, so we can achieve the required strength, which whatever strength we are having, so this mixed proportion ratios we can taken care of, so that our requirement strength of the concrete is obtained. As in RCC case, here also we can get those strength by making this ratio of the finance to fly aggregate to GGBS ratio. So that we have seen that we can achieve those results also by using this geopolymer concrete. So studies on geopolymer paste is also overgoing the evolution microstructure of GP based and GP with age has been shown. You can see 1 day strength 2.9 megapascal. As you can see that this ratio in this case GGP is 7 to 30 ratio. This is for this part GP4 part, in which fine aggregate to GP is 7 to 30. In this case microstructure views we have shown. So these are the 3 days strength 3.3 megapascal, and this has been on the micro level we have taken these pictures, and this is the 7 day strength 6.4 megapascal. So this is the thing which we have been done by the 6.4 megapascal, and after 28 days strength is 20.4 megapascal. You can see how the strength is going on by different days, as in the case of RCC also. So by this we can understand that geopolymer concrete also produces results similar to that of normal concrete by using OPC. So here, but cement is not there, so CO2 production is less. That is why carbon footprints are less, and we are achieving the desired strength. So by this ratio variation, we can get the required strength of the concrete. So these are the research parts which are going on, and evolution of this microstructure with molarity for GP4. So you can see that when the microstructure of with molarity for GP4 we see for 7 days strength is say for 6 molarity it is, you can see different molarities we have tried. So, so this is for 7 days strength. Molarity is 8. Molarity is 8. Then we can see the strength is 4.8 megapascal. You can see our strength is varying with the molarity. When fly ash to GGBS ratio is 70 to 30, fly ash to GGBS ratio is same, and it is 7 days strength, but with molarity strength is changing. So that is why we have changed the molarity also in this case. You can see 6, 8, 10, 12 for GP4 and 12 for GP1 to GP11. That is why our molarity is also affecting the 3 days strength or 7 days strength we can see. So that is why by controlling the molarity also, we can change the different strength at for the same number of days. That is also one part. So as the requirement, we can mold the different molarities as per the requirement. Whatever strength we want to achieve in 7 days, we can accordingly make the molarity 6 molarities, 8 molarity, or 10 or 12 we have tried here. Yes, you can see 7 days strength is 6.5 megapascal, 7 days itself for the same fly ash to GG base ratio, 70 to 30 ratio. That is the reason why it is also moldable. Like in the previous case, water cement ratio was changed. In this case, molarity we are changing so that we get the desired strength. These are the different research we have done. So in this case, you can see that these are the figures which we are doing on. So these are molar sources. So by this molarity, we are playing with the strength achievement in the required 7 days. That is the part which we have done in this case. Then findings on page, but after this research, we find that what is the findings on the page? Strength is more than the OPC page. You can see that it's achieving strength by different changing motifs. So strength is more than OPC page, and setting characteristics depends on many factors. And because initial final setting temperature, it depends on many factors, can be used for grouting also without curing. In this case, you can see it can be also used for grouting without curing. That is also one important part because curing water is required, but in this case, water is not required. In that case, it is curing is without curing, without means grouting is done without curing. That is also we are saving the water also. That is why findings on paste are very much on positive side so that we can get the required strength. So now geopolymer mortar we can like we have discussed geopolymer mortar we have made something like this. So studies on geopolymer mortar also done. After this, these studies is done, then mortar composition and series design of geopolymer mortar for different fluid binder because we are using here fluid binder ratio, not water cement ratio. That is why we have using this now what fluid binder ratios and mortar proportions we have changed. Fluid to binder ratio is 0.35 and GM A series we have taken 0.2 for GMB series. This 0.2 is 0.35 and 0.2 is fluid to binder ratio. Okay. So, for the 0.35 fluid to binder ratio and 0.2 fluid to binder ratio, this is called GMB series and this is called GMA series. And molarity M of sodium hydroxide is taken 14. Molarity for fixed molarity, we can see that for the different fluid to binder ratio, they have our result. In this case, binder composition is fly ash to GG basis. 100 in this case 100 to 0, then 90 to 10. Different binder composition we have taken. Then series designation we have taken, mortar proportion we have taken. So according to that, GMA1, GMA2, GMA3, and GMA4, GM up to G11, GMA11 we have taken. You can see the mortar proportion is 1 ratio to 1.5, and this GMB1, G1, GMB2 we have taken. A series is for 0.2 fluid to binder ratio and 0.35 ratio, and B series is for 0.2 to binder ratio. These are the different series for different binder ratio. So then in this case, we have made some definitions and then we studies we have plotted in this graph. We can see that studies on geopolymer mortar, we can see that variation of strength with binder composition and age at constant flow of 75 to plus minus 5% is there. In this case, this is the graph we obtained. And this is 20 days strength you can see. 14 and 7 days. So you can see that this series we have obtained from GM to F up to this series we have plotted in this graph. We can see that how this ratio is changing with the compressive strength after the 20 days, 14 days, and 7 days. You can see that 28 days we are getting this strength. This is the way how we are getting this strength in the different geopolymer ratios. These are the compositions we have taken of this 100, 90, 70, 30 different. So by this playing these ratios, we can get the different required strength. As different cases of RCC mix we got, this geopolymer concrete can give this same type of different results as per the variation of the variation of the binder to cement ratio, and this is the thick binder ratio. These are the parts how we can get the different strength. Like in case of the, I am just showing that how the different strength in this also can be obtained by varying this fly ash to GG base ratio and varying this molarity ratio and varying this fluid to binder ratio. The same way we can get the results also in this of geopolymer concrete, geopolymer mortar. So this variation of strength is to fly ash to GG base ratio for different edges at different constant flows obtained in this graph. So This shows that it is also applicable for the other parts also. As per the requirement, we can vary the geopolymer mortar ratio so that get the required strength. Further graphs we have plotted for the variation of strength with molarity of NaOH. Now molarity is changed. For different molarity we have plotted. Molarity is changed 6, 8, 10, 12, 14, 16, 18, 20. And we can get this variation of strength with molarity. We can, as we have already discussed in the previous case also, molarity changes we have shown in this previous case also. But like this 12 molarity, 10 molarity, 8 molarity, 6 molarity is here. That is the thing. By changing the different molarity, we are getting the different strength. So same way we have plotted this graph. This is the way NaOH molarity is there, which we have plotted for 20 days, 14 days, 7 days. For this different molarity, we have obtained this graph. So these are the things. So these are the things we get by changing the molarity. So you can see that molarity is important part as per the requirement 3 days strength, how much we require. So molarity also is important part to get the required strength. That is the thing. This graph is showing that molarity also you can correlate with the compressive strength. Whatever compressive strength we required by changing the molarity, we can get it in 3 days also. By different molarity, we get the different strength of the means our geopolymer mortar. So further studies on geopolymer mortar has been done. The variation of strength with mortar proportions you have shown. Mortar composition and series generation of GP mortar for different mortar proportions we have done. Then we are making this fly ash to GP ratio 40 to 60 and molarity of NH is 14 and this fluid F by B fluid binder ratio is zero point 0.4. In this case, different mortar proportions we have taken. A binder to QT ratio we have taken here and this is 1 ratio 1, 1 ratio 1.5 and series generation we have taken. So this also we have again plotted this graph. You can see this graph.
100% कब्जे का भी एडवांस ही होता है
So you can see this graph. So after this, we can see that
वाटर वाला का ही मिशन नहीं होता
here volatility is fixed and fluid binder ratio is 0.4. So that is why our average compressed tank is seen by different variation of this binder to fluid ratio we have taken. In this case, we have plotted this and different tanks we have obtained for different ages. So this way we can see that by using some different compositions, we can get the results similar to RCC concrete means concrete results also we can obtain by using varying this volatility and varying this binder to fluid ratio. These are the things by which we can get the required strength and required results as in the case of the concrete part also without using the cement. That is the research area that we are getting those results which were using our concrete also. We are getting those results in this geothermal concrete also by using by making the molarity changes and making the this ratio of binder to fluid ratio. So this we are getting so that we can get the desired results as in case of concrete. That is why it is very much useful. Without using cement, we are getting those results. Geopolymer composites in this we can use that water to cement ratio is less than partially saturated are there and fully saturated are there means W by C ratio is less than 0.3 and W by C ratio is greater than 0.3 it is called fully saturated and this partially saturated use solids liquid plus air and solid liquid only in case of fully saturated case. Then it is partially saturated is called mortar, fully saturated in concrete, and it is suitable for making bricks or blocks, and this is suitable for making structural materials in which greater than 20 megapascal strength is required, and this requires compaction, and this requires may not require compaction also because here we are not using water, so that's why compaction may not be required. In this case, W by C ratio is 0.3. So geopolymer blocks we have made manually made, and then hydraulic press we have made curing conditions like in curing here it is done without water. That is very important. In this we are doing curing without water. Water is not required. So you can see that without water heat cured and ambient curing is there without water. And geopolymer blocks are considered by manually made and hydraulic press. Then in curing conditions we can say that heat cure is done or ambient curing is done. In this case, both case water is not. So you can see this that water is saved in this case of the geopolymer blocks. No water is required during the curing. So that is why we are saving the water and also we are getting the required result as in case of concrete. That is why it's important. So you can see this how it is done. You can see like a material is mixing in dry condition. There is no water in this, and that is why we are getting this in the dry condition without having the water. That is the thing by which geothermal company is becoming popular because of the less use. So these are the things in which by which geothermal it is made mixing in dry condition. You see there is no water. It is solution is there and other things are not there. Without water it is being made. You can see solution we are making. We are not putting water. So that is a important part which you can see is this for the research part that we can using molarity, different molarity. We are using binder ratio, fluid to binder ratio we are using, and we are not using water. Without curing, we are getting the things. That is why it is very important. But these solutions are made in lab, so that is why special taken care of. It cannot be made by common persons, so that is why some expertise people are required in this case for making the required solution. So that what our desired strength is obtained by making proper molar solution. That is very important in this case. So this alkaline fluid is added. We are not adding water. This is alkaline fluid. In this beaker, this alkaline fluid is not water. That is very important to know. And you can see gloves are used here. It is not like open-handed. We can use that. We can use the gloves because it is dealing with the solution, not water. That is why gloves are important in this case. Let's see how it is made. Using gloves, we cannot use bare-handed because it is reactions can take place on your hand. That is why we are using gloves here. And mix to get the homogeneous mix. You can see in this. And again, same process we are doing. We are weighing on this. We are making required quantity of mortar. We are weighing in this figure. And Mirdini developed at IAC for solid device book. So means this different maps has been made. So in this IAC Bangalore, this digs has been made. Geopolymer compute. They have made something geopolymer, some make presses using lever manually. These are made. So the instrument for the geopolymer compute. A mold is lubricated before using this to make the required mold. And these are the things like we are using this glove. So these are to be handled, taken care of by some expert people. It is not like that you can use it. So this is like this we are doing on research. So this we are making. This mold is filled with harsh mortar. Make this mold. And now this is closed. Then mold is pressed with cover plate manually. Like this mold is pressed with cover plate manually. And fresh block is ejected. Using this fresh block is ejected. So injection of the fresh. And after this, height of the block is noted. And see, this is geopolymer block. And then neatly it is labeling is done for this. And it is cured in open air. No curing is done in water. It's cured in open air. And three-phase system is there in this case. One is mortar is made of solids plus liquids plus air. Solids means binders and aggregate. Binders means whatever we are using for using this binding part. We are not using cement as a binder here. So liquids, here solids means here binder and aggregate, and liquids means here fluid because we are using here solution. That is why it is liquid is replaced by the word fluid and air is replaced by the word voids. By using this binder plus aggregates plus fluid plus void, we make the mortar in three-phase system. Now geopolymer block is tested for the compression. A block with the crack after testing something like this cracks is seen. That block king static and vibro compaction is there. It's filled with mortar. Again, it's filled with mortar. This cover, this cover of is done after this cover is made like this, something like this. Compacting hydraulic machine will compact it, and then block is taken out, and then cured in open air. Cured in open air. Mass production of the blocks is done. Then blocks in field become technically wrong. Similarly to blocks with different shape and size we can make. As in the concrete, similarly way we can make the different size, this shape PV1, PV2, PV3. As per the requirement, we can make in different size as in concrete because that is the main important of concrete. You can make it in different sizes. That is the thing that also done here in geopolymer. Dimensions of the block, you can see that it is different. PV1 is for size. This is PV2 output to output. This is this much. And this is PV2 output. This is three sizes there, something like that. Center diameter also something. The ambient, the important thing is that these are ambient cured blocks. No thermal input is there, no traditional curing is there, no demolding is there, and only compression keep ready. That is the main important part. We are not doing any water. We are using ambient cured blocks only. And thermal input is also not required there, and traditional curing is also not there. Demolding is also there, not there. Only compression keep the ready. It ready. Heat cured geopolymer blocks are also there. This case, geopolymer machinery blocks, heat cured is oven is either ambient means in open air we are curing. And in also we can make them heat cured also. The heat cured oven is at the rate of 60 degrees Celsius for 24 hours. We will put those blocks in 24 hours at the rate of 60 at the temperature 60 degrees Celsius, then it is heat cured. And ambient cured is open air. So those two types of curing is there in this case. Ambient cure or oven cure, heat cured. The heat cured is done in oven at temperature 60 Celsius for 24 hours. We can see strength versus fluid to binder ratio. You can see this compressive strength is this. Fluid to binder ratio, we have take changes from 0.15 to 0.25. Okay. So these are the fluid to binder ratio different are there. So you can see compressive strength is changing. Fluid to binder ratio, we already know because here we are not using water. So we are using here solution. That is why it is called fluid. And this is why binder we are not using cement also. So water to cement ratio is now changed to water to fluid to binder ratio. That is why terminology is here fluid to binder ratio, not water to cement ratio. In this case, heat cured blocks we have seen. In this case, you can see that. In this case, you can see that compressive strength is there. This is the variation compressed strength. Fluid to binder ratio is there. Then different after this different days strength is there. You can see this plot. Same way you can get those graphs as in case of the have cement concrete which we have done in this case. So you can see these results. The strength is changing as per the requirement of the this into this, and this is the two boundary ratio that is being changed. Means whatever things we are achieving in the concrete, we can achieve here also using the split to binder ratio. That is the thing. So we are getting those same things, similar things which we used to obtain in case of the cement concrete without cement. That is very important part. Without cement and without water also. So that is the part which we are having some important part that we are not using here cement, neither we are focusing on water, but we are using fluid to binder ratio and we are getting those similar results and different shapes also we are getting. You can see this shapes also we are getting. So an ambient curing is there. These are its different shapes and their curing is ambient curing is there. This no thermal input is there, no traditional curing is there, no debonding and only compression treatment. These blocks are there, the geopolymer machinery blocks are there. So that is oven at the rate of 60 Celsius for 24 hours we take ambient cold is there. That is why open air is there, the strength versus fluid to binder ratio, but we are getting the same. That is the important part why geopolymer concrete is useful nowadays as per the requirement for the sustainable construction. Because sustainable construction it is there because we are not using, we are reducing the use of CO2 because we are not producing any cement here, and also we are reducing the use of the water. That is why it is sustainable construction because neither cement is required nor water is required. Both of them are very important in terms of the environment because CO2 will be required and more amount of cement is required then CO2 will be more. The water is not there. That is why water loss of water is also not there. And our quality of water and use of water will be less. And since construction is going at a higher pace, these things are very important because if we do not take care of these things, then lot of CO2 will be produced, which is not very useful for the environment. That is the thing. Now MBL cured geopolymer blocks are there. In this case, we have done each of the sample 1 day, 3 days, 7 days, 14, 28, 56, 90, 120 and 180 days. We have seen these parameters and fly ash, different fly ash, as I told you, different FE1, FE2, FE3 we have taken from distance source. And alkalinity activator we have to use because we are using here solution. So that is why I told you to make the solution, sodium hydroxide and potassium hydroxide is required. The ratio of binder to aggregate is there. In this case, 1:1 is there, 1:2 is there, 1:3 is there. And degree of saturation is 40 and 60%. Molarity of alkali solution we have changed from 8 to molarity. The fine aggregate is there for sand, quarry dust, and pond ash. Fine aggregate we are using from the sand, quarry dust, and pond ash. And temperature we are maintaining 25, 30, 40, 50, 60, 70, 80. And binders we are using here as fly ash, GGBS, silica film, metal. Fluid is here solution. Binder is here as fly ash, GGBS, silica film, metal. These are the binders. This is variation of temperature, and fine aggregate is sand, quarry dust, and pond ash, which we are using. Molarity of alkaline solutions 8, 10, 12 molarity. Because molarity solutions we have to make by some expert, which everyone cannot make those 8, 10 molarity. So that has to be taken care of. Whatever requirement is there, that has to be taken care of properly. Otherwise, if solution is not made proper, then desired properties will not be there. That is why molarity of the solution which we are making, we should take care that if it is 8 to 8, if it is 8, then it should be 8. If it is 10, it should be 10. Means whatever required molarity solution is required, then it has to be made. Otherwise, it is very difficult to make the solutions. Okay. The degree of saturation is 40 and 80%. Ratio of binder to aggregate, this you have to maintain. We have varied these things, and we have varied the binder also. We have varied like fly ash, GGBS, and silica film and metacolumn. So after that, we have done some study. So we have, after this, we get this F by B is fluid to binder ratio 0.2, 0.25, 0.25, 0.75. And then compressive strength is there. After this age is seen. You can see that after the as the age goes on, the strength is increasing. After this number of days, 100 days up to we have taken up to 180 days. So we can see that 180 days, this up to this strength is there up to 180 days. Strength is after this becoming constant. So we can see that same way complete graph is coming. So same way to binder ratio graph is coming. So similar results are obtained in this case also. We can achieve those results. That is very important. That is the reason why this study is relevant as for our environment. Things show that quality of this result is very much important. As it is showing the same graph, same strength achieving this of using the water and cement also. So without water and cement, we are getting those results. That's not good. Strength development age, we can see that for different like this compositions we have taken like this. These different compositions, we have plotted something like this. And this is the average composition strength. So this is the age and days for this different compositions we have taken BR3, BR2 as per this different compositions. So now different cementation material. Typical stress strain curve also you can see. This is normalized stress and this is the strain. You can see that it is something like that in geopolymer circuit you can see. And this is the modulus of elasticity. So you can see the series ID we have given this. And this is the average compressed strength. This is 0.25 into average ultimate strength. Roshan Anand, I think your marker is going on the screen.
Sir,
Roshan Anand.
sir, you can remove that person if someone is creating problem. You are the co-host of this program, sir.
Roshan Anand, please do not do it.
Who is this person?
Roshan Anand.
एकदम रिस्ट्रिक्ट कर दिए, क्या नाम है? रोशन आनंद.
You can see this series ID. Yeah, it is there.
Dear participants, please do not do. This is the first event I have noticed.
average ultimate compressed tank we have taken care of. This is the average compressed tank, and this is the point defined, and we can see. So I think some child is sitting on his computer. I think
Sir, he is removed from this group.
secant modulus is there. So weight loss with elevated temperature is there. Then it is we can see that constant deviation average weight loss is there, and this is the one. Then the theory test on the blocks we have seen. Then loss of water to cement content as per the ASTM. We can see that loss of mass is 2%, water is 2.4%. We can see that these are the constant duration of 4 hours. We can see. So this is the things which we can obtain the model test. You can see this. It is in the RCC concrete also. You can see the similar curve is there. So maybe due to this, you can see that it is related to something like this. So you can get those similar behaviors of RCC concrete. Then it is something like this. Then the durability test on blocks also is there. Then loss of mass and water content as this STM is something like this. Then geopolymer blocks as machinery. Then we can use it. So means we can use it bricks also, solid blocks also, hollow blocks also, and wallets also. So we can see that geopolymer brick wallets, casting of geopolymer brick wallets is there. Then it is used in this different area. So stretched bonded concrete we can see geopolymer brick wallet kept for curing something like this. So these are the prototype models which has been made for the research part. So their results are well taken care. Geopolymer brick wallets are there. So testing arrangement of geopolymer brick wallets are there. So that has been done. Some in lab testing is there. Then later arrangement for the geopolymer brick there. The later arrangement of eccentric loading is there. Geopolymer solid block wallets is there. You can see eccentrically loaded wallets is there. The vertical cracks develop from bottom. These are some studies which shows that how the failure pattern of axle loaded wallet is there. And geopolymer hollow block wallets are there. Testing arrangement of this also done. Geopolymer hollow block wallets are there in this case. Average complete strength we have seen, axial loading and eccentric loading. And the strength of eccentric loaded block wallet is 80%, 84% axial loaded wallets. This is obtained. So pictures of machinery structures in field. This has been tied in some building has been made for the geopolymer concrete. So results are okay as per the requirement. Application is there. So no change in dimension bricks is there in the wall. Brick edges remain sharp and no erosion, no thing is there. Less water absorption there, no distress is there. Even after 2 years, there was no sign of any deterioration of the walls of the Jipoma brick model house. The roof of slab is casted after 24 months. So you can see this model is showing that no erosion, no pitting, less water because water is also less, no distress is seen, and no change in dimension bricks and the walls is there. And roof of slab is also casted after 24 months. Then thermal comfort during the winter is there. That is also there. You can see that ambient, this is the ambient temperature, and this is temperature and GPM. So thermal comfort is also there using this GPBS. So this is the geothermal concrete which has been made. And these are the studies on the geothermal concrete. The parameters considered for geothermal concrete is concrete to proportion binder PUD-C ratio, 1 ratio, 2 ratio 3, and sodium silicate and to sodium hydroxide ratio is 2:1, molarity is 10. So we can see that sodium hydroxide ratio we have to take care of, molarity we have to take care of. Then slump is 100 to plus minus 10. And this is the series generation we have made. Binder to composition ratio fly ash to GGBS is something 101 and 80 to 20 and 60 to 40 and the different fly ash to GGBS ratio is there. And fluid to binder which is there 0.65, 0.65, 0.7, 0.75, 0.75. So you can see that different fluid to binder ratio is there. So as per this, we can see that we can take control as case of in case of cement concrete also we vary something like this. So here also we are varying our composition by using this fly ash and GGBS and fluid to binder ratio, and we can get the desired result. So that is the important part. We are getting all those results in which we are getting in case of concrete. So that is why our research is relevant in case of the requirement because you can see we are getting this structures something is no after some observation made in geopolitical machinery there is no change in dimension breaks in the wall and bridge edges also remained sharp and there was no erosion no pitting and less water absorptions are there and there was no distress even after 2 years there was no sign of any deterioration of the walls of the geopolitical brick model house. So geopolitical brick model house has been tested and it has been obtained the roof slab is also passed out before month. But no erosion, no pitting, best water absorption, no distress using this geopolymer concrete. So means their practical applicability is very much taken care of. So you can see this similar way, this pictures of machinery structure in field. And the essentially loaded blocks, you can see that hollow brick wallets as per the load at first track has been observed like in axial loading, static loading, and compressive strength also we can see that. So these are the parts which we show that geopolymer concrete part is also in the application part in field also it is showing good results. That is why it has been useful as per the requirement. So we can go for this. Thermal comfort is also there during winter. So geothermal concrete making is a useful source in terms of the sustainable construction because we are making this sustainable construction without use of the cement and without use of the water in curing. That is why this is important. We are making molarity solution. In this case, we are not using water also, but different compositions we are here changing like fluid to binder ratio we are changing. We are changing the fluid fly ash to GGBS. This cementitious metal can be GGBS or different source which we are making. So slump also we are making 100 to plus minus 10 mm. And series delineation we have taken for different like for fly ash to GGBS ratio 100 ratio 0. GC1 is there and GC2 is 80 to 20 ratio. So by this, we can see that different, see, as per the different requirement of the work, we can vary this binder composition and we can change this fluid to binder ratio so that we can get the desired result. For reference concrete, this concrete proportion of security, we have taken something like this. So based the studies on geopolymer concrete, then we can use for NC. This was reference concrete is NC means normal concrete and GC is geopolymer concrete. So mass density for geopolymer concrete is 2424 to 2516 kg per cubic meter, and for normal concrete to 250, as we already know, normal concrete is mass density is 2504 to 2550 kg per cubic meter, and compressive strength we have compared for those. So because we are using normal concrete earlier, so that's why we have compared for both. You can see this compressive strength. This is fly ash to GGBS constant, and this is the age in days, and this is the variation with respect to age. And this is variation with respect to fly ash or GGBS. This variation we have taken fly ash to GGBS variation is something like this 180 to 20. So for different ratios for mixed proportion. So this is the ratio. Fly ash to GGBS is 100 to 100 to 0, 80 to 20. Instead 40, 40 by 60, 20 by 80, then 0 by 100. So these variations we have taken on different age strength we are seeing. And this is the variation with respect to age, which we are seeing. Okay. The compressive strength, we will see this in megapascal. So we can see this is the NC is normal concrete, and this is the GC1, GC2. You can get this as per different parts. So this age variation is there. So we can see this normal strength is something like this. But in the geochemical concrete variation, you can get the strength more than this also as per the requirement. Mixed proportion is 1 ratio 2 ratio 3. This is the mixed proportion 1 ratio 2 ratio OPC 2 CA ratio concrete also here. Okay. So this ratio we can see, so we can get the required strength with the ages also. So we can see that we are getting the required results by comparing with the normal concrete also. We can get the requirement of the result as per our requirement of the work. So it is not like that. It is not only saving it is not only making the sustainable construction, but also it is making the relevant results also in terms of strength. Means whatever strength we have to make, we can take the care of the fluid to binder ratio and molarity ratio, and we can get the required result as per the requirement of the work. So that tailoring property is there in which concrete is proper because of this tailoring property, we can make the get the results as per the requirement. That is why this tailoring property is there in this of geothermal concrete. That is why it is also more popular, and it is not in terms of the but it requires some expertise to make because we have to make some molarity solution. And as you can see that it is also we have to take precautions in lab to making this molar solution. That is why it is not simple as making. Some common persons cannot easily make it. Otherwise, they should they should have some basic knowledge of some using of those things because persons has to be trained to make this required solution so that required things are made. So that is important in this case of. So that is the part. That is the why it has to be taken care of before making those things. So variation with respect to age there in this case you can see by different lies to GGBS constant. We are getting this graph for different ages, and for this also we can see variation with respect to age. So again, studies on geothermal concrete split tensile strength has been also done in this case. So for different fluid to binder ratio, you can see that mixed proportion is 1:2:3, and 90 days, 50 days, 20 days, 7 days, 2 days. The split tensile strength is also seen, and this is normal concrete. You can see that split tensile strength is also that GC6 is a good split tensile strength in this case of compared to normal concrete. You can see this, and in this case of different ratios, you can see this different for 90 days. This is strength for mixed proportion 1:2:3. So you can see that geocomp is also showing good, not only good compressive strength, also a split tensile strength. This is split tensile strength, and this is the compressive strength. In both cases, you can see that more than normal concrete strength we can get in geothermal concrete by varying the mixed proportion, by varying the fluid to density ratio, and by varying this fly ash to GGBS content. Okay, so that is very important. So split tensile strength is there. So that is also good, and so with respect to normal concrete. So we can say that properties are as good as normal concrete. It is not very much less in case of the geothermal concrete. So that is why it is saving also our water, also saving our cement, CO2 emission also, and but giving the results as good as required by for the different works. That is why we can go for the geothermal concrete for making the things eco-friendly or sustainable construction. Then structural strength also has been checked. Then you can see normal concrete structural strength is something like this, and this geopolymer strength in GC6 case it is something new. So we can see that for different ages also, we can see that we can get the required strength by varying the proportions in different geothermal concrete, so that we can get the results more than the normal concrete also. So means it is more feasible, and as it is means properties we can tailor the property. It is not fixed that only this much result it will get. As per the requirement, we can do variations in the geothermal concrete by using the molarity variations, by varying the fluid to binder ratio. This will make the difference in the strength output. So what this can be achieved, that is why it is also useful in making the required strength as per the tailoring property, which is very important in concrete. That is why concrete is more popular, because we are making them tailoring property. Tailoring property is also there in the geothermal concrete, so that it makes the sustainable constructions with the required strength also. So these are the things. Then studies of geothermal also done on this shear strength also. So you can see that this strength, you can see that after this shear strength also with the normal filter also it has been checked in this shear strength part. So we can see that that is also as per the requirement. We can tailor it as per the requirement. That impact strength is also used, and this is the Scudder's impact testing. Specimen size was taken 150 and diameter to 60 thick. Then impact energy is taken in this case of W is 4144, H is 0.45. Number of blows to cause failure has been checked. Fly ash to GGBS content has been varied 100, 0, 80 to 20, 0 by 100. Then next proportion, then final failure will be something like this. And impact energy in case of, and first track is shown something like this. That has also been checked. Then pull out strength test also be taken care of in this case of geothermal concrete. You can see the mix proportion we have changed. So geothermal concrete specimen 1 or specimen 2 we have taken. So pull out strength we have taken bond stress and with respect to slip. This is showing the pull out strength. We can see that slip is there with respect to this. So specimen 1 is specimen 2. That is also has been checked. So we can see that by deflating, varying the fly to GGBS ratio 90 to 30, and making different geothermal concrete contents, we can change the pull out strength also. And then further typical testing curve has been obtained, and this is the normalized testing curve for geothermal concrete for different areas. So we can plot it by some regression model. You can see that we have taken, so this is for molarity 10. For different molarity you can get the different molarity and fly ash to GGBS ratio 7 to 30, and fluid to binder ratio is 0.65, sodium silicate to sodium oxide is 2 ratio 1. For this we have making test stain curve. You can see it is similar to concrete part. So by this, we can see that it is also getting those required results as per the normal concrete also. So that's why the behavior is similar to that, but we are getting say, making this without using the cement and without using the water. So that is the main concern. That is why it is making the solution for sustainable construction. That is why it is important for our future generation, because we are saving the environment without using those water and without using those cement. CO2 is also less and water is also less. That is why we are getting the required curves also as per the requirement of our field. So in the end, we can compare this. The conventional concrete is this, geopolymer concrete is this, strength on hydration is there in this case, and this strength is coming in from hydration in case of conventional concrete, but in geopolymer, it is strength is coming by geopolymerization plus hydration. And cement is the binder in cement, this case of the uh, normal concrete. And for this geopolymer, fly ash, GGBS are the binders in this case. And water to stream carrying is there in this case. In this case, thermal carrying is there. Only fly ash is there. And water is used for mixing in conventional concrete, and alkyl solution is used in this case of geopolymer concrete. And definite procedure for mixed design, and geopolymer concrete is having developing stage, because as I told you that there is no geopolymer code, but it is in draft mode right now. So, but there is no there is no fixed procedure for making IS code for mixed design. So that will be also soon it will be made. And this is cement concrete is something like this. In this case, we are using water plus activators, aggregates, DGBS, PFF, products concrete, and geopolymer concrete. Something like this is made. So that is the it is in developing stage. Its code will be soon are in draft mode, so it will be coming in this later part. The concluding remarks are that geometry polymers can be developed in line with the Portland cement product also. High compressive strength and durability is more used for special applications like precast industry, fast grouting, high early strength machinery units, and lining of furnace. These are the special applications. And geopolymer concrete satisfy slump also, compressive strength also, split tensile strength also, impact strength also, shear strength also. So without OPC and curing. The GML concretes are satisfying the slump requirement also, compressive strength also, split tensile as we have seen in the graph. It is satisfying the all. So these all the test it is passing, and without using the OPC and curing. That is very important. We are not emitting CO2 in this case, and we are not using water in this case. That is why our things are achieved without using the means CO2 emission is not also very much not there, and curing of water is also required. So means we are getting the requirement which we are having at the site without using the sources which are not available in the environment or producing pollution. So that is why sustainable construction requirement is met in this case of geothermal concrete. That is why it is nowadays part of research, and many people are doing this research so that its code is also in formation. Nowadays, draft has been made of the geothermal concrete for roads, but for buildings also it will be also soon coming, because lot of tiles are there, so that it is certified by different sectors that it is the requirement, it is the okay for the field people, because we know some expertise is required in making these solutions in this case. That is why it is not friendly for all people, that common people cannot use it. That is why our expertise has to be there to make this geothermal concrete. That is the reason geothermal concrete are still means not very much used in the field, because some expertise people are required in this case. So that is the reason we have to uh, use some expertise people and make our codes more popular. So these are the things. So thank you.
Thank you, sir, for your presentation. If anybody has a question, you can write in the chat box, or else the session is ending it. This FDP is getting over, and you will have the quiz at 8 o'clock. So, thank you, sir, for your presentation.
Okay, thank you. Thank you.